In this question, we've got a 10 kilogram mass, which I'll just make a quick little sketch of. There's our 10 kilogram mass, and acting upon this mass are two forces. One of them is 40 newtons, directed directly north, so we'll assume north is to the top of the page. We'll call that F1. And the other one is directly to the west, and it's only 30 newtons, so I'll draw it a little bit smaller, and we'll call it F2. Now the question asks, what is the resultant acceleration if that mass is pulled on by those two forces? Well, we know Newton's second law says that if we can figure out the net force, which is the overall combined unbalanced force, then we can determine the acceleration. As long as we have the mass and the net force, we can get A. So how do we get the net force? Well, by definition, the net force is simply the sum of the forces that act on the object. But because forces are vectors, you have to sum them up according to the rules of vectors. So we're going to add these together tip to tail. So we're going to add F1 plus F2, and we're going to make that diagram, and that's going to equal my net force. So F1 was 40 newtons north, so it's going to look like this. Now at the tip of F1, we're going to start the tail of F2, which is 30 newtons to the west, so a little bit smaller. And we're trying to figure out the resultant, which always points from where I started my diagram down here towards where I end my diagram up here to the finish line. It has a direction, and that's important. So this line here is what we're trying to figure out, and that's going to be called F net. Well, the nice thing is with this question, we've got a 90-degree angle between the 40 and the 30 Newton force. So to solve for F net is a simple matter of using the Pythagorean theorem. So my net force will simply be A squared plus B squared. Those are the two legs, all square rooted. A squared plus B squared equals C squared. So to get C by itself, we take the square root. And when we do that, we find our resultant is 50.0 newtons. So now we know the net force. And since F net is ma, we can solve for the magnitude of the acceleration fairly easily. The mass was 10 kilograms. So I've got 10 kilograms times my acceleration equals 50.0 newtons. Dividing both sides by 10 gives me an acceleration of 5 meters per second squared. So we have the magnitude. Now, what about the direction? Well, the direction I'll do in blue. If I'm trying to find this angle right here, I know the opposite is 30 newtons, and I know the adjacent is 40. Notice I avoid using trig ratios that involve F net because I already calculated that to be 50, and I may have made a mistake, so I'm going to use the original numbers if I can. So I know opposite and adjacent, so that's tan. So if I go tan theta is opposite over adjacent, but I want to solve it for theta, so I got to do the inverse tan. And when I do that, I end up getting 37 degrees, and that would be swinging to the west of the north line.